Well, thanks everyone for joining us, especially in these interesting times we have going on, shifting gears for remote. I want to thank you all for joining us. I think we have a couple people coming in, so I'm going to wait just one more minute to let people join, or maybe a couple minutes, and then I'll give a short intro into Holberton, and then we'll pass it along to Redis. Perfect. Okay, cool. So as everyone fills in, I just want to give a quick hello and welcome. So hi, my name is Kristen Lloyd. I'm the resident software engineer at Holberton School's San Francisco campus. And normally I would introduce you to the space, but in this virtual space, we're going to have to postpone that. But what I'd love to do is give you an introduction to Holberton, our goals, what we do, and what makes us special. So Holberton School is a 2-year full stack software engineering program where students learn how to learn through projects and peer learning. Across 9 global campuses, Holberton's mission is to give students the opportunity and tools to learn how to code without formal teachers and lectures and without the financial burden of traditional payment options. We do this by using income share agreements, so students only start paying for their education once they get a job that meets a certain threshold requirement. So let's kind of talk about what everyone wants to know. What do the students learn? Even before that, let's talk about how the curriculum was built. It was built with the intention to equip students with the knowledge and skills that the industry needs and wants, technically and socially. To do that, our curriculum is reviewed by individuals in the industry, hiring managers, senior engineers, CTOs, and team leads. And we also incorporate student and community feedback into our revision process to make sure we're always up to date with what is needed. As far as technical skills, students spend their foundations year diving into C, Unix programming, Python, database management, DevOps, and general best practices for coding, such as test-driven development and professional commit messages. Some milestone projects include creating their own printf and shell in C, and creating a clone of a website from scratch, including server and database management. So that's the first year. The second year is their specializations year, where they go deeper into one of many possible tracks. Low-level programming, where students dive deeper into Linux and C programming, building on what they learned in Foundations, while adding more challenging projects such as while adding more challenging projects and data structures, web stack development, machine learning, in which students learn supervised, unsupervised, and reinforcement training and work on projects such as object detection, speech to text, neural transfer, and more. AR, VR, where students learn C# and Unity. And available at some campuses, career track, where students focus on honing their resumes, portfolios, and interview skills with the intention of finding a job in the tech field. So while Holberton students build their technical knowledge, they work on their social skills through short presentations, updating their peers on their progress and challenges, asking questions, seeking help, and offering support to others. There are also various partner projects throughout the curriculum, so students get practice coding with others, planning and agreeing on architecture of a project, and version control practices like using Git branches and pull requests. And while the curriculum is an extremely important part of Holberton, we wouldn't be where we are today without the software helping us provide access to this curriculum. It checks the code at scale and it schedules project releases. Students and staff have access around the world through the user interface, and the software team has built the tools to allow us to support large cohorts of students by automating the checking of their code for plagiarism and for accuracy of the code. In this way, we can deliver high quality education to many individuals at once and ensure high quality code from our students. So great, we have the curriculum and the software, but what makes us really different is how we approach learning new things and solving problems. We've put together something what we call the framework, which is a process of steps working through if you have a question to solve. So by pushing our students to consistently follow these steps when solving problems, they learn how to approach a problem and learn when to escalate to the next level, from reading available resources, to asking why, to doing more research, to connecting with a peer, to connecting with a mentor. In this way, students don't just learn how to code, they learn how to learn. And with that, I'm just super excited to have this event today, because as our students are learning more and more, they're learning about databases, and they haven't yet had the chance to work with Redis before. So with that, I would like to say welcome once again to the Intro to Redis Commands and Data Structures. I would welcome you all to come to our campus once we are back on track to be there. And if we can have virtual events, that would be great too. We'd love to welcome you. So Dave, I'll hand it right over to you. Thank you for being with us.
Great, thanks a lot. I am tuning in live from my home here in Mountain View, California. Thank you for having me. And by the way, so I know things are all different for everyone, and we're all trying these things for the, well, not the first time now, but the first few times. If anybody has any trouble, Drew is also online with me, and he can take questions via the chat, and I will be answering those as well later on, or as I go, as I see them. But I just want you all to feel like you can ask questions. No question is too simple or too stupid or anything like that. I think there's a lot of people who are new to Redis, perhaps on this call, and quite frankly, it's very popular, but there's large numbers of people still learning about it. So yeah, feel free to ask any question. And so let me go ahead and share my screen, and we can get going here. But by way of introduction, just to give you a little background, my name is Dave Nielsen. I head up community at Redis Labs, and I have been in the web market, then the cloud market, and now I guess the database market for about 20 years or so quite a while. And at one point I was learning it just like perhaps you are today. And I can tell you, I started off by learning an SQL database. So that's one of the things I want to talk about on this webinar. Now I think you can see my screen now. Let me go into, somebody tell me if you can see this screen okay.
Yeah, looks like it, Dave.
Okay, good.
Looks good.
All right, very good, thanks. All right, let me get the chat going here so I can at least see that. All right, so this is an intro to Redis data structures. Now, before I get going too far down this path, I just want to let you know that Redis is very, very popular. And I want to explain a little bit about that, because some people might say, well, I've never used it. I don't understand why it's so popular. Well, according to Stack Overflow, which is, you should get to know Stack Overflow for sure. It is a website where you can go ask questions, and there's, basically lots of people like yourselves or like myself or in between who have answers and will answer your questions there. But according to, and they have a large number of users. And according to Stack Overflow, they do a survey every year where they ask a very extensive number of questions about web technologies, internet technologies, cloud technologies, developer technologies. And one of the questions they ask is, which database would you most like to use? In other words, which database do you love the most? And for the last 3 years in a row, Redis has come up #1. And again, it may not be the first database you choose, but it's extremely popular. So let me drill into that just a little bit, so you can kind of understand where we're coming from here. If I were standing in a room of experienced web developers who've built many applications, and I asked them, how many of you have used Redis? A lot of hands would go up, probably 90%, like tons of hands would go up. But if I asked them, okay, now how many of you are going to use Redis in your very next application as your first database, very few hands would go up. And so that's kind of an interesting dichotomy. Why are everyone's saying this is great, I've used it, and yet they're not going to use it in their next, as their first application in their next first database in their next application? And the reason is because Redis was originally built to help applications scale. And specifically how that was used is if a database was being queried a lot and it was getting too many queries and those queries were heavy or long, and the database might not have been able to run that query enough times to keep up with the web traffic. And so if the data wasn't changing every millisecond, maybe it's only changing every second or every minute or every hour, then running that query and then caching the results so that the web application could access that cache for the next period of time would dramatically relieve the load off of the SQL database. So that is still today a very popular use case for Redis. Another example would be, let's say a whole bunch of data is going into your database, and you have like a bunch of IoT devices, or just maybe a lot of users, swiping on their phones or something like that. And all this data is going into your database. Well, again, writing data to a database can actually be slow. It can be put a heavy load onto that database. So instead, what you could do is you could write the data into Redis, which can accept it easily, very, very fast, and then write it in chunks, so batches, into your permanent database somewhere where that data is, it can be more easily written in batches at a time, and your SQL database can handle that. So Redis oftentimes gets used as sort of an in-between database to handle caching of long-running queries or ingesting large amounts of data and then writing it in batches to some SQL database. And so why do developers love it so much? Well, they probably started off with another database, like a SQL database, or some other NoSQL database, and then they start running into problems of scaling. And these problems oftentimes happen at a point where you're just becoming successful with your application, or it's a critical moment. I mean, every moment is a critical moment when you have live users. And all of a sudden you're having these troubles and scaling, and people are unhappy, and you're getting complaints, and you're like, oh my gosh, what do I do? And somebody's going to tell you, you should try Redis. And it's very quick and easy to set up. It may not take you, depending on what your problem is, it may only take you minutes or at most hours to implement a solution and have your website running quick again. And so, for that alone, it deserves to be loved because it's solving a very painful problem at a very important time. And whoever is using Redis to solve this problem can be seen by the rest on the team or the company as like, the hero. All right. So yeah, for that alone is probably why it gets this positive reputation. But there's so much more to Redis. So we're going to go ahead and talk about that. All right, let's see, here we go. All right, so how is Redis different from other databases? So at the high level, it is extremely fast. It is not only fast for a database, it's fast for a NoSQL database. And NoSQL databases are known for being fast. So it's basically the fastest of all the popular databases. It's also very simple. It has many different data structures that each data structure can solve a different problem. But each one of the data structures is very simple. And what I mean by data structures, I mean, when you put the data into Redis, like how is it being stored? Is it being stored as a string? Is it being stored as a row, like you might put in a database table, or as maybe in lots of little tags, as ones and zeros? How is that data being stored? And depending on which data structure you're using, it would be stored in a different way. If you're learning Python, you may have learned about the different structures in Python. You can kind of think of Redis as being like that, only it's in a database form, which all of your different web servers can access in a shared data set. In fact, Redis originally stood for Remote Data Store. So it was sort of like a place to share your data with other applications and other servers. And then it's also very extensible. We have these things called modules that give you all this additional capability. So if you're someone like a developer or somebody and you need more capability than the 10 data structures that you get with Redis, if you're sophisticated enough, you can start building that capability in C or Rust or one of the other programming languages or even Python, I think. excuse me, and you can then compile that into a Redis module and load that into Redis. And now you've given Redis the ability to have some additional capabilities. And we'll talk about that more in a moment too. Now, Redis is extremely fast. Why is it so fast? You can see here it just completely blows doors on the other databases. The reason for that primarily is because it is an in-memory database. That means when you write data to Redis, that data stays in memory. It also writes it to disk, but it never, when you're asking Redis for data, it's never going to disk and saying, give me that data off the disk and then give it back to the application. That data is always in memory. So if whatever you write to disk, there's also that data in memory. Therefore, whenever you want to go request that data, it pulls it out of memory and it's very fast. And a little more specific on that, it is important to know that by default, Redis, when you're writing to Redis, by default, when you write to Redis, it is writing into memory, and then it is responding back to the user or to the application before it commits it to disk. So in that way, there is a slight moment there where if by the default configuration, if your server were to go down, you could lose some data. However, to overcome that, there's two things you can do. You can tell it when you write to Redis to make sure that it's writing to disk, and it will write to disk before it responds back to the user. Or you can also set up a cluster of Redis where there's multiple instances of Redis, and you essentially have the master, and then you have a replica. And you can tell it before you respond back to the user, write to the second replica so that you now have that data in both Redis instances, the master and the replica, before it returns back to the user. And again, you'll have the confidence to know that it's written into more than one place. So, Redis is preferring speed over almost anything else, but you can make sure to do these extra steps to make sure that your data is safe. Okay, so now let's talk about data structures. You probably don't recall this particular screenshot from a movie, but maybe you do. If you happen to know what this is from, what movie this is from, you could write this into the chat window just for fun. I'm not going to give out prizes or anything, but if you know what movie this is from, go ahead and type it in the chat window. All right, so this is from a movie called 2001: A Space Odyssey. And it's actually from 2010, which is the follow-up movie, looking back at 2001. But in the movie, this astronaut goes out into space, and he's looking at this really unusual sort of oddity. It's called a monolith, and it's this black shape in space that's like 1 meter by 3 meters by 9 meters, or something like that. Maybe I have it wrong. I think it's right. Anyway, so it looks black, but when he goes up close to it and peers inside, he sees that it's all full of stars. It's like, amazing, right? Like, how could it be full of stars? And Redis is kind of like that. When you think about Redis, people think of it as this key value database where it's like a key, and then you get this string, and then you can cache data into that string. And sure, yeah, that's how you can use it as a very, very simple cache. But there's a lot more to it. So when you look into Redis, you will notice that there's a lot more. It's very interesting. And here are the 10 different data structures plus PubSub that you have right out of the box without having to do anything, just installing Redis, and you will get these data structures. And let me just go through them real quick, high level, very, very fast. And you can take a look at the example they give you that gives you a little bit of an idea of what might be stored in that data structure. So first you've got a string, which lets you just simply put some text in there, like literally put a sentence or a word or whatever you want. It's a binary safe string. You can even store an image from or a video or something in there. It'll come out exactly the way you put it in. And then we've got bitmap. Well, I'm going to bounce around here a little bit because I like to tell it in a different order. And down the second blue one there, you've got hashes, and hashes are kind of like rows in a SQL database where you've got field value, field value, field value. And this way, if you want to store information about a user, you can put like their the first name, the field is first name and then the value, which in my case would be Dave. And you can say the second field is last name and the value, which in my case would be Nielsen. So you can store a whole bunch of field and values in there. Again, it is kind of like a row in a table, kind of, not really, but kind of. And this is also very popular. So strings and hashes are very popular. Then let's bounce around a little bit. Let's go over to lists. So lists right below hashes is essentially a way to put data that you want to process later. So if data is coming in, like maybe you're ingesting temperatures from a IoT device, or you're tracking swipes on a phone from users, you can pass all of that in really, like as it comes in really fast, put it into a list, and then you could pop, so that's called pushing to one side of the list, and you can pop off the other side of the list. And it's just keeping track of the order in which they come in so that you can take out the first ones that come in, you can take them out and then put them in the database. And it'll kind of queue up there for a while you're taking your time to write into the database. Then you've got, and by the way, they're called double linked lists. So each one of those items knows the item before it and the item after it, but you can't, like, there's no index. So it's not very good for like finding things in that long list. You're just going to be able to find what went in recently or what went in earliest. And then we got sets. Sets in the upper right hand corner there. It's just a bunch of unique values. So let's say you wanted to store a list of all of your friends. Well, you don't need to store your friend IDs more than once. So you can put them into a set. And it's a very fast way to store a bunch of unique values. Or let's say keywords like tag values. If you're describing a product, you don't need to have the same description word more than once. So you can put them in there. Or if you're trying to store unique IP addresses of unique visitors to your website, one of the nice things about sets is if you did try to add a second word, a duplicate word, it would just ignore it. And that's built in. It does it on purpose. So it's very, very fast, easy way to store non-duplicates or unique values. Okay, then we got sorted sets. They're in yellow. Sorted sets is kind of like a set in that it has a whole bunch of unique values like user IDs or friends, whatever. But then you can also store a score or a number. And then what happens is that set of unique values gets automatically sorted by that score. So if you were playing a game, you could have user ID and then you can have the player's score, and it would be like a leaderboard. You can use this for a lot of other reasons. All right, then you've got bitmaps. Bitmaps over in pink. That's a bunch of ones and zeros. This is a little bit more sophisticated to use. We won't get into it too much today, but you can use this to store unique, like on or off statuses of items. Like, is this product available for sale? Is this user currently online? Each one of those ones and zeros can actually be uniquely addressable and can represent that user. A very, very efficient way to store massive amounts of valuable information in a very small space. And a bit field is the same thing. They're the blue one right below it. It's instead of ones and zeros, you can store larger numbers. And this might be really good for ingesting analytical data, a bunch of data that you just want to dump all at one time into a key. All right, then we've got over on the right-hand side, geospatial indexes in green there. Geospatial indexes is basically if you want to search nearby. So it's going to store the like an item, like a description or an entry, and then you're going to also store the location of it. So it actually you can give it a latitude and longitude, and it will store that in a way that you can then search to find all of the items that are near where you are right now or near a particular latitude and longitude. And then we've got hyperloglog below that in green there. And that is a really unusual one. It's got a fun name, hyperloglog, but it also gives you the ability to store basically how many times an item has been stored in a very small amount of space. So if you're keeping track of words and things like that and how often they are how many unique words, for example, there are in about a text. Let's say like all of Wikipedia, which would of course be like terabytes of data. You could actually count all those unique words and store them in a hyperlog log, and it would probably only take about 12K of space. So it's a really, really powerful way of counting things. And then we've got streams. Streams is relatively new. It was added a couple years ago. And this is a very modern way of storing event data. So when something changes and you want other applications to know that it changed, the old way to do that would be to use PubSub, which is right below it in black. And what you would do is you would tell Redis, hey, this channel called channel 1, here's some new value. And then it would send that value out to all of the other applications that have called into Redis and said, hey, I want to listen to what's changed for channel 1. And so it might be listening to product orders or chats that people talking in a chat room or something like that, and sending it out to the different clients that are listening, like chat clients, or fulfillment systems that need to know that a product has been purchased. And it would automatically send that message out to them. However, it doesn't retain any history of what messages have been sent or items have been sent. So if for some reason that information was sent but not actually heard, then that information would be lost forever. Whereas with streams, what happens is it's basically doing the same thing. It's saying, hey, I want to send this information out to all of these other clients that are listening, but they can, if they don't receive the information, then they can come back and get it, because I'm going to retain a history of the information that I have sent. And then if they have received it, they can then send back an acknowledgement or an ACK back to the server saying, hey, I have received that information. And so now you'll know what information has been received and what hasn't. Okay, so there's the 10 different data structures plus PubSub. And these are very powerful. They're very fast. They are very, some of them are more popular than others, but these are the data structures that give Redis its power and its capability. Okay, now you can extend Redis. These new extensions that have been coming in over the last few years give Redis the ability to do things that maybe other databases do. So it sort of extends Redis to become like other databases. For example, if you want to do search, you can use the Redis search module, and you can do like keyword search or search locations. You can search all sorts of stuff with Redis search. Redis time series stores data that has come in a sequence, in a time sequence. So like if you're tracking like where you're going and you want to track every 1 minute, like your location, it would then store that information very effectively and efficiently, so that when you searched by history, it would be very fast to pull out the data of the locations you've been in over the last period of time. And of course, if you go more than like a week, you may not care anymore where you were every minute. You might just want to see how often you were in a particular place over a period of a month, and it would compact all the information so that when you did that search, it would be very, very, very fast. Then you've got Redis JSON, which is a way of storing document data, sort of like MongoDB. So if you are getting started with a document store and you wanted to store your data in JSON, you can use Redis JSON to store that information very efficiently and effectively, so that it would have some indexing capabilities and other things that you would use when you're storing data in a JSON database. Redis Bloom is a probabilistic data structure, very similar to that hyperlog one I was talking about, where you can do really cool analytics, well, not really analytics, but statistical counting. So if you want to see how many times a user has come to your website, or if you want to know, does this item exist in this large catalog, you can just quickly look there to give you a yes or no. Redis Graph is like a graph database. So if you've ever used Neo4j, or if you've ever wanted to store data where you have relationships between large amounts of items. So like, I want to know which one of my friends lives in a town or has read a book or has maybe a certain age or lots of multiple attributes, and you want to search through a graph of people and their friends or a genealogy or relationships between businesses or where people have been, that might be a very great efficient way of storing that data and searching through it fast. And then Redis AI is probably not for you guys, but maybe, I don't know, it depends. If you're doing deep learning and you want to store your model on a server so your applications can access, infer or predict something, you can store the model in Redis AI. So you can store it in Redis. And if you go to that URL, you'll be able to see other models that are, other modules that are available for you. Okay, so let's get into a couple here. Now I'm skipping the most obvious one. I shouldn't probably do that because it's something that you probably will want to use, but I'm skipping caching. Caching is very easy to do. It's like that use case I talked about earlier where you built an application and you're using some other database, like a SQL database, and the queries are really slow. Well, you're gonna wanna cache that data, and you're gonna use the string data structure probably, and you could use the hashes data structure too, which is what I'm gonna show you in just a moment. But you could just use the string data structure, and it's so easy. I should just show you, but you literally have a command called set, and you're gonna pass in the string to set along with a key name. So you might say user 1, and then you could put the user ID. Or you could take the entire HTML from a web page, or maybe just a table, or maybe just a section of text, and you can store that in that string. And then what would happen is your user who's visiting a website might, or all of your users might be requesting the same information over and over again. You just store it in that key, user, or maybe it's the front page news or something like that. You're going to store that in Redis so you don't have to keep going back to the database. And so you'll say set, let's say front page news is the is the key, and then you put all the text for the front page news in that value, and then you'd use the get command to get it out. It's really, really simple. I'm taking a little sip here of my water. Okay, so let's get into some more of this. Yeah, by the way, I highly recommend if you're going to get started with Redis, and again, I feel like now that I'm talking about this, I should have gone back and shown you this example of the get and the set, but it is really, really easy. If you need to do it, you can go to redis.io, click on commands, and you can see the set command there, and that'll tell you how to set the data, and get will tell you how to get the data. It's really easy. Let's take a look at a user session store. This is the first example that I was going to show you today. And in this user session store, this would be an example where you build an application. Let's say you're using Ruby on Rails, and Ruby on Rails, typically you're using it with Postgres or maybe with a SQL database of some sort, and it automatically generates a lot of your tables. And so what's going to end up happening is your queries might be slow, and you might start to cache some of your queries. Once your application becomes popular, you might start caching some of your queries in Redis, like I just mentioned a minute ago. That's the fastest thing you can do, the first thing you can do to speed things up. The second thing you can do is you can take your user login information and put that in Redis. And what I mean by that is the way that your web applications typically work is when a user logs in, it's going to take that data from the login, and it's going to take your user ID and password, first of all, and compare that to the user ID and password it has in the database. And it's going to see if they match. And if they match, it's going to say, oh, okay, this person is user 1 or user Dave or whatever. And so we're going to allow them in, and we're going to put a little cookie in the web browser that they're using. And that little cookie is going to get sent back to the application every time they make a new request for a web page. And that cookie is going to be associated with this particular user. Now, that session ID, so that cookie ID will be associated with that session ID. That session ID oftentimes is stored in the SQL database. So that means every single time you go back to the web page, you request a new web page, it has to go to the database and see, is that user logged in or not? And that's a lot of times to hit the database, the SQL database, for something so simple. And plus it's really that is a perfect example of a key value lookup, and you're doing it every time. You might as well put that in memory and speed everything up. So it's put that in Redis. Just if you run into any speed problems whatsoever, put the user session information in Redis. That'll help a lot. So that's sometimes where you call a user session store. And so Redis is a very good user session store. Now, oops, sorry, I didn't mean to go ahead. So notice here in this example that if you are using Redis, and if you're using another database and you're also using Redis, you could put Redis on the same application server where your application code is running. You could do that if you only have one application server. So if all of your application code, web application code, is on one web server, then you could put Redis on that one web server. But if you're going to put if you have more than one web server because you're scaling and you have more users than can fit or than one web server can handle, then you're going to want to put your Redis on a separate server. And you're going to have to go across the network, but Redis has some nice pipelining techniques that really help speed that up or make things more efficient. But the most important thing is you're reducing load off of your SQL database. And so you're going to get all the benefits of the speed. Even though you have to go across the network, it is still much, much faster than waiting for a slow database. Okay, and so information you can store in the user store, you're going to store this in a hash data structure. And again, you can store user session state. So is the person logged in? And multiple web servers or app servers can access this. You can store multiple variables in there, like first name, last name, user ID, that kind of thing. And it's very fast. And in this case, you're going to use the hset command. And just like set, you can go to redis.io and go click on commands, and you can find out more information about hset. You're using hset to set multiple, one or multiple session variables. And you're going to use hget to get one or more values back out of the set data structure. Again, this is kind of like using a row and a table. So if you're familiar with the SQL table, this is kind of like doing a select and getting the values out of one row, or maybe doing like a insert or an update to set the values of one row. And then we've got a bunch of other special commands. So each data structure, in this case, it's the hash data structure, has its own specialized commands. hset, that H, by the way, stands for hash. It's not always so obvious, but in this case it is. And the H increment by means you can tell one particular field, like a counter in that hash data structure, to increment. So every time you come back to the web page, you can have it increment the number of hits to that web page. You can also set the key to expire. So this would be great that after 20 minutes, if you want that user session to go away so that they're not logged in forever, you can tell this key, hey, I want you to expire after 20 minutes. Okay, and then after 20 minutes, that key no longer will show up when you look for it, and that user will have to log in again. Okay, let's see. I'm wondering if I have any questions. No questions yet. If you have any questions, feel free to ask them in the chat window. Okay. All right, and here's an example of the data, of the commands that you would use from your command line. So I didn't want to put code here in a particular language because you're probably all using different programming languages. But if you were to log into Redis from your terminal, basically Redis has something called the Redis command line interface, or the Redis CLI. When you install Redis on your laptop, if you're on a Mac or Linux, you can also do this on Windows, but that's a different story. There is a way to run Redis on Windows 10 fairly easily. But once you install Redis, it gives you two applications. It gives you the Redis-server, which is Redis itself, and it also gives you Redis-CLI. And the Redis-CLI is essentially a command line. It allows you to type in commands into the window, into your terminal window that will then call the Redis server as if your application were your application code were talking to Redis. And here's some examples right here. hset user session 1, okay? That's how you set the key. That's the key. Redis is known as a key value database, and more than that, but simple way to think of it as a key value database. And then in this case, it's a set data, it's a hash data structure. So you are storing field value, field value, field value. So you got user ID is the field, and then the value would be 8754. Name would be the second field, and then Dave would be the value. IP is the third field, and then you can see the IP address there with the port. And then hits would be the fourth field, and then the default would be by, first time you go would be a 1. And then here you can see a second command that you can pass in called hget, and you want to get some of those fields or all of them out. If you say hget user session :1, then you can pass in the individual fields that you want, and it will return them. Now you may be wondering, why is there a colon in the key value? So the key is user session :1. Why is there a colon there? And the reason why is because Redis doesn't have a hierarchy of keys. Basically in Redis, all of the keys that you set in Redis are stored at the top level. They are not organized into tables or collections or anything like that. So if you want to store your keys in a way that is somewhat organized, then what I recommend you do is take what would have been the table name or the collection name and use that as the prefix, then use the colon, and then what would have been the unique index value in the table or in the collection, and use that after the colon. So in this case, user session may have been the table, colon, and then 1 would have been the unique value or index for that table. And then you can think of the field values as values in that table. So that's the kind of commonly recognized way of creating your keys. And here you can see the next code is h increment by, user session is the key, and then you're saying, I want you to increment the hits field by 1. And then I can say, you know what? I no longer need that. I'm gonna use hdel to delete the field called hits from the hash data structure called user session 1. Now, I talked about expiring keys. It is very common to expire keys for sessions. So in this case, you're basically saying, I want to expire this user session 1 in 10 seconds, okay? Or I can just delete the whole key altogether. All right, so that's how you would use sessions, or that's how you'd use, hashes to store session information in Redis. All right, let's take a look at number 2. This would be the managing queues of work. This is that use case I talked about where you've got a whole bunch of data that you want to move into another database, or a whole bunch of work that you want to perform, but you may not be able to perform it as fast as the work gets created. So you can use queues, and queues uses the list data structure. Okay, so again, you've got lots of work that needs to be performed. Like, for example, you have an order, an e-commerce order that's coming in, but for each e-commerce order, you need to go and put data into a bunch of different tables. You need to send a message to maybe another system to let the inventory system know that it should decrement the amount of items available in the inventory system. You need to send an email out to the user saying, hey, we've received your order. Oh, and of course you need to send process the credit card. So all these things might go into a queue because it takes longer to do all those things than it does to simply process the web page. So the web page gets processed, it puts all the items into a queue, and then later on some other service comes along and pulls the data out of a queue and performs the work. Okay. Like another example is you simply want to dump a whole bunch of data into a SQL database that's coming in from the website. You can just buffer it all into Redis and then batch it into the database. And we're going to use the lpush command. You can actually use the lpush or rpush. I actually don't know if the lpush stands for list push or left push. I don't know, but I've always thought it was sort of like left push. So you're pushing an item to the left side of a queue, and rpush would be to push it to the right side of the queue. That's how I always thought of it. Never really figured out if that's true or not. But it also has a really interesting command called rpop lpush. And what that'll do is that'll pop the value off of the right side of the queue and push it to the left side of the next queue, the second queue. And you basically pass in the names of the queues to the app to this command, and it pops one item from the right side of the first queue and pushes it to the left side of the second queue. So this is how you can move data through and say, okay, I've gone ahead and processed the credit card. Now I need to go ahead and send the email, and you can order the work that needs to get done this way. All right, let's take a look at how this actually works in code. Again, this is just a command line, so it's not actually your Python code or PHP code or whatever, Go or Node.js, but you can do this from this is exactly what it would look like from the command line. And here you have your queue, and the data's coming in. First, I'm going to ask you a quick question here. You don't have to answer this, but oh, somebody's trying to answer a question over here. Yeah, lpush, right? Thank you from Drew. It looks like inserts all the specified values at the head of the list stored at the key. Right, but what does the L stand for? I still think it stands for left, but it could stand for list. All right, so, but if it stands for list, then what does the R stand for, right? Hear me? Okay, so the question is, looking at this Q:1, which item was pushed in first? If you're using lpush, well, then in this particular case, task 1 would have been pushed in first. And you can see what's happening here. Task 1, and then task 2, and then task 3. And then we did this rpush, which actually pushes it to the right side of the queue, which kind of is cheating, right? It's going to the front of the line. But then when you do your rpop, you're going to pull what's on the right side out first. So that'll be the front of the line. Excuse me. Okay. So let's see what happens here. Here we go. So now I can take the rpop lpush. I can pop that task 4 off the right side of Q1, and I can push it to the left side of Q2. So again, this is how you can say, okay, the work has been done for Q1, which might be Q where you're processing the credit cards. Once you've processed the credit card, you do the rpop lpush, and you put it to Q2, where you're now sending out the email confirmation. Okay, let's take another, go on to the next one. Let's take a look at real-time leaderboards. Now, I gave you, I already talked about this one a little bit. This is where we have the sorted set, okay? And in the sorted set, what's gonna happen is you might have many, many players playing a massively multiplayer online role-playing game, or just any of these online games where you have large numbers of players. And imagine you're playing Fortnite or something, and there's millions of players, and all of them have some sort of score somewhere, and all of that's going into some giant leaderboard. Can you imagine millions of players having scores changing in real time in one table in a database? It just would not be able to handle that. But in Redis, you can. Being in memory, you can do things a lot faster. So Um, so that's when you might use a sorted set. And in a sorted set, commands typically start with a Z. And Z add is how you would add the user and the score. Z increment by is how you would update the score for that user. And Z reverse range is how you would get out a range of users starting, basically with the highest first based on score. Okay, so let's take a look at what that looks like. So Z add, game:1 would be the leaderboard. So that'd be like the game that we're all playing is the first game. Maybe you're using maybe you're supporting multiple games. And user ID or game player A, we call it ID A, is going to get 10 points. Player B is going to get 20 points. Player C is going to get 30 points. Player D gets 40 points. And then all of a sudden, player C now gets another 20 points. So you can see how it went on the leaderboard from being having 30 points to now having 50 points because you incremented it by 20. And then if I want to pull out basically all of the players, I can say just give me everything by game 1, starting at position 0, and give me everything. Okay. All right. So that's how you would create a leaderboard, and this can be used for a lot of things, not just games. But for example, in tech life, you're building a website, you might want to keep track of the most popular web pages that visitors are going to. So your user in this case would be the web page ID, and you'd increment how many times it gets viewed. You might want to keep track of error messages. So when a web page responds, if it gives anything other than the OK, if it gives like a 404 error, you might want to pass in the error message as the ID, the user ID, and then every time that error message comes in, you increment it. So then your user ID is basically the error message, and then the most popular error message would rise to the top. All right, so let's take a look at the next one, which is geospatial indexes. And this is again where you're going to be searching what's nearby. Okay, now this is actually built on top of, or at least leveraging, the sorted set data structure. And so while the commands I'm showing you here, you would use geo as the, any command that starts with geo is going to be for geospatial indexes. There are some Z data structures for sorted sets that you can use on these data structures as well. So like to delete one, you actually use zdel, which just deletes the geospatial index. Okay, so this works really well if you've got many items that are moving around within a geographical area. So for example, if you wanted to build your own ride sharing app or some sort of app that's letting you find people nearby, or restaurants, or other items, then this would be a good data structure for you to use. It helps track things moving in real time, and it's going to give you what are the nearest items now. And yeah, SQL queries for something like this might just be far too slow. All right, so let's take a look and see how this works. All right, so now I'm not going to get into a ton of detail about how this is working inside because I think it's just too much for today. But what happens is you're going to create essentially a collection of entries called locations. So if I want to track, in this case, I'm using the airports. So that IP address, I'm sorry, not IP address, that latitude and longitude right there is the latitude and longitude of the San Francisco airport, which is -122,375 and 37.618889. Though that's it's actually the longitude and latitude, I think. And you pass that in. And so what GeoAdd is going to do now is it's going to say, okay, I have an entry called SFO in my locations key, and that is the latitude and longitude. It does convert that latitude and longitude into a geohash, which is basically a one value. And then it uses that one value to search. but it does have a special algorithm that lets it know which values, how to know which values are nearby. So it's not just a linear search, it also knows by quadrant on a map. That's why I put the map on the left side there. You can see those little squares. Each one of those squares actually would have a value. So I'm not going to go into more detail and explain that, but it is clever the way they do it. It's not 100% accurate, but it's super accurate. So it's very, very convenient to use for you. Okay, now let's talk about PubSub for a second. PubSub is, earlier I mentioned how you might use PubSub to notify other applications, or let's say you have a collaborative calendar and you have multiple people who are scheduling, let's say, meetings in rooms, maybe at your school or something, and you don't want people to schedule the same meeting at the same time somebody else is. So you both have your web browser open, and somebody goes and schedules a meeting in room 1 at 1 o'clock. Well, you want everyone else whose browser is open looking at that day to have room 1 at 1 o'clock all of a sudden be marked as blocked off. So you have to have a way of letting that other person's browser be connected to the server so that it can receive this PubSub notification telling it that, hey, you need to now mark off room 1 at 1 o'clock. So PubSub allows you to do this. The way you do it is you have the clients or the web applications subscribe to publishers, and then we're going to use the subscribe command, and then we can also use the publish command. So it's pretty darn easy. Here's an example. I wanted to show you how this works in a way that would help you understand the difference between PubSub and streams. So let's say, I go to my command line. I'm going to do a Redis. I'm going to have 4 different terminal windows open. And my first one, I'm simply going to make sure Redis is running. So I'm going to go to command line. I'm going to type redis-server, so Redis is running. I'm then going to run flush all just to get all the data out of there so we know that it's empty. All right. And now I'm going to open up another terminal window, and that's going to be my publisher. I'm going to run my Redis CLI in that publisher terminal. And step 1, I'm going to go ahead and type publish channel 1 and then hi 1 in quotes. Now I'm going to go to my subscriber 1, open up a terminal window. I'm going to run my Redis CLI. And I'm going to type subscribe channel 1. And my question to you is, will subscriber 1 receive hi 1 from the publisher? Think about that for a moment. Specifically think about the order in which the information was provided. Okay, so the answer should be no. It's not going to receive it because it subscribed to channel 1 after channel 1 had already published hi 1. That's right. So Ian, you got it right. It subscribed after the hi 1, so it didn't receive it. Now I'm going to go say subscriber 2. I'm going to launch my 4th terminal window, and I'm subscriber 2. I'm going to run the Redis CLI, and I'm going to say subscribe channel 1. And again, it will not have received the information. Now, I'm going to go ahead and say number 4, step 4, publish channel 1 hello 2. And what should happen is both subscriber 1 and subscriber 2 will receive that hello 2. Now I'm going to go to subscriber 1 and I'm going to Control C and cancel out that window, so it's no longer connected to the server. And I'm going to go to step 6 and I'm going to say publish channel 1 hello 3. And what should happen is my subscriber 2 will get hello 3, but subscriber 1 will not because it's no longer connected. It's no longer listening to channel 1. But then I'll go back to subscriber 1. I'm going to run the Redis CLI to get it back up and running again. And I'm going to type subscribe channel 1. So now it's listening again. And I'm going to say publish channel 1 hello world 4. And so subscriber 1 and subscriber 2 will get hello world 4. So I did it in this order so you would understand that any information that is published while a subscriber is not listening will be lost. It'll be like the subscriber left the building and you said something and then it came back in. You'd have to say it again for that person to hear it, okay? But this is a very simple system to set up, and connected. Uh-oh, I'm getting a message here that my internet connection is unstable. Let me just stop just for a moment. Okay, so hopefully you guys can all hear me still. All right, so that's how PubSub works. Now, if you want more reliable messaging, similar to PubSub, you can use something called streams. Redis streams is more complicated, but it does give you more reliability. So if you need to make sure that the order that somebody made gets delivered to another system, you can use Redis streams instead of PubSub. And you're going to use the X commands. So X add to add to a stream and X read to read from a stream. There is actually some more subtlety to this, but that's the idea. And let me show you how this works. Okay. And what happens is you're going to publish an event. And this means that the information is going to be published and distributed to other applications, but the consumers not only will receive the information, they can actually acknowledge that they received the information. And if for some reason they did not receive the information, they can go and ask, hey, is there any information that I haven't received? And it will tell them, okay? So this helps a lot in, again, real-time communications between complicated systems, especially systems that have ebbs and flows of data and you don't want to overload them. You can simply add more publishers or add more subscribers as needed. So here's how this would work in this particular example. What's going to happen here is, again, I'm going to set up my 4 windows. I'm going to have a producer. We call it a producer in Streams World instead of a publisher, and we call them consumers instead of subscribers. But I'm going to say X add my stream 1, which is basically a stream name. And I'm going to give it an asterisk, which basically says, hey, I'm going to leave it up to the server to create the timestamp. And then I want my entry field to be greeting. And I'm going to say hello 1. Okay. Now I'm going to go set up my streams. My consumers, and consumer 1 and consumer 2. And I'm going to go through the same process I did of disconnecting consumer 1 after it's already read the first time. And then while consumer 2 will be up the whole time. But they're both going to be able to go back and read what entries have been added to my stream 1 when they weren't listening. So you're going to end up not missing any data, even though consumer 1 started after the producer had begun, and even though it turned off in the middle and completely missed the real-time communication of hello 2. Once it comes back up and is listening again, it can then hear everything that's happened before and since. Now, this is a very, very simplified version of how this would work. It's not how you would typically do it in real life, but if you try this, it will receive all of the information. Okay, so we're getting down to the nitty gritty here. We're almost done. Let me just review real quick. We talked about hashes, which is, we kind of skipped strings here, but well, I guess I'll come back to them in a minute here. So we talked about hashes where you can store record-like information for users who have logged into your website, and you're storing information about that user, maybe about that user's particular session. Okay, not just that they're logged in, but maybe their first name, last name, other common information that you might have to go to the database for. Then you've got the list data structure, which gives you the ability to store data in the order in which it was received. This is great for ingesting data, for keeping a queue, to keep track of work that needs to be performed, that kind of thing. Then you've got sorted sets, which gives you the ability to have like an index that you might use to store the top of anything. So top scores in a game, top error messages in at your website, top web pages view, top pages viewed, that kind of thing. Then you've got geospatial indexes, which give you the ability to search and find out items that are nearby. And again, very scalable. So like Uber or Lyft could use this kind of thing. And then you've got strings, which is very, very simple. You're just storing a string of text or an image, or a string of bits, whatever you want to store in there. And it stores it in memory, so it's very, very fast. You can set an expiration on that so that it expires after a period of time. By the way, just a quick note, let's say your web page is getting 1,000 hits per second. Okay. If you store if you're querying your database 1,000 times per second, that could put quite a load on your database. However, just caching that value for just 1 second, it means that you're going to relieve that SQL database from being queried 1,000 times per second. It's going to go all the way down to 1 time per second. That is dramatic workload reduction just by caching data for 1 second. That's pretty powerful. Okay, and then bitmaps, like I said, you can store ones and zeros. If you wanted to, you could store, these are all uniquely addressable ones and zeros inside of a value. So if you wanted to, you could say, okay, that first bit is my user user 1, that second bit is user 2, so on and so forth. And then if you wanted to find out who's currently online, so for example, if you're building some sort of a person-to-person chat application, you can say, okay, I need to know which one of this person's friends are currently online so they know who they can click on and chat with. Well, then you would basically have a key for each person, and in that key would be a list of their friends, and you could quickly grab that list of friends from their friends list data structure and then pass that into this bitmap, and it would then return only the friends the friends ones and zeros, basically the friends that are currently logged in. Very, very, very fast and efficient way of identifying who's currently logged in or what's currently available in your website. And then bit fields, we talked about these. These are where you've got the unique values. I'm sorry, not unique values, numbers that are being passed in, kind of like bits, but instead you have more complex numbers. Great for storing analytics in real time. You've got sets for storing unique values like tags or unique IP addresses, etc. Hyperlog, where you can store probabilistic data structure. Like, if you go to Google and you do a search on Redis, you're going to get like, okay, Redis appears, I forget what it is, like 45 million times or something like that on the web. And, is it exactly? No, because it's 4, 5, and then 0, 0, 0, 0. But it's a good enough, it's good enough estimation, right? So that's a good probabilistic data structure to use for that problem. And then streams we talked about, and PubSub we just recently talked about. So that's about it. I can take questions, and feel free to ask them. We see we still have most of the people on the webinar. If you have any questions, feel free to ask them. Otherwise, if you have any questions, you can email community@redislabs.com, and either Drew or I will answer them. And while you're thinking of questions to ask, if you have any questions, I also want to let you know that we have an online conference coming up in just about a month on Tuesday, May 12th, and Wednesday, May 13th. We have our Redis Conf, which is usually in San Francisco in person. But this year, we, with the coronavirus, of course, along with a lot of other people who are canceling their conferences, we don't want to cancel it, so we just moved it online. And you'll be able to join us live online for our keynotes, and we'll have all of our sessions pre-recorded so you can watch them anytime. And you can go to redislabs.com and click on the link in the upper corner to go to the event, or you can just go to redisconf.com, redisconf as in Frank.com, and that'll redirect you to the right page. And it is free to join. The training is free as well, so I highly recommend you take advantage of that. And one last thing, since this is a lot of you are still learning, if you want to use Redis for free in the cloud, we have a great solution for you. Just go to redislabs.com and in the upper right-hand corner, choose try, put in your email address. And what's going to happen is we are going to give you a free Redis cloud account, and you can use this up to 30 megabytes, which isn't a lot in the real world, but for just learning, it's plenty. And you can then point that Redis CLI command line to the IP address of the Redis server that you get at Redis Labs, and you can actually interact with Redis in the cloud. So that's a great free tool to use. I highly recommend it. All right, I think we are all done. I don't see any questions, so maybe I just did a great job, or hopefully I haven't been talking to myself this whole time. All right, so if you have any other questions, feel free to post them. Otherwise, we'll make sure that these slides are available through the meetup and through the college, the university, if you'd like. Oh, look, hold on a second. Do you have a question? Okay, we'll definitely be looking into using Redis on projects in a few months. Great. Yeah, use Python to build your website. Yeah, please do. Python's great. You can use both Flask and Django have clients for capabilities with Redis. And thank you, Padmaja, for your compliment. Appreciate that. And I hope that we will see you online. Again, you can go to redislabs.com, and you can also go to redislabs.com/community. And we have some community resources there, both events that are coming up, online events. We've got links to blog posts. We'll probably list this event up there, and you'll be able to watch a replay of this. So go check out redislabs.com/community, and you can subscribe to our Redis Watch newsletter. And I see that Pierre has also commented, so thank you very much. Yeah, you're using JavaScript React with Express and MongoDB. And yeah, you can use Redis to speed all that up, absolutely. And for other examples that we talked about as well. And you asked, do you have recommendations in terms of best resources or materials you can use for implementation? To find out what a command is, I highly recommend that you go and take a look at just redis.io. Also, there are some great YouTube videos at redislabs.com/tech-talks. And we do have a link there from the redislabs.com/community page. So if that didn't come out clear, you can go there. There's also just tons. Oh, I forgot. There's also Redis University. So if you go to university.redislabs.com, there is literally a university quality course that I think it lasts about 6 weeks. It's just a couple of hours a week. It's really easy. But there's many courses there on different programming languages that you can use with Redis. There's Node.js, there's Java, there's I think Python. There's quite a few there. And there's ones on various modules like Redis Search. Definitely take a look at that. That's gonna be high quality material there. And then finally, I also want to point out, if you just simply go to YouTube, there's a lot of intro to Redis videos there. They typically tell you how to install something for your particular programming language. You can type Redis Python or Redis PHP or Redis, and you'll usually get Redis Laravel, whatever programming language or framework you're using. They'll usually walk you through how to set it up and how to do your very first Redis cache. But they typically don't tell you about all these other data structures that are available. So that's why I like to talk about them in this talk. So that's a good resource. YouTube is your friend. You can pretty much find, if you say Redis user sessions or PubSub or streams, you'll find videos there. And also, one other resource I want to point out is we have a couple of ebooks on our website. So if you go search for if you go to redislabs.com, and then I think we have them listed at the very bottom of the community page. So if you go to redislabs.com/community and go scroll all the way to the bottom, there's some ebooks there. There's one called Redis for Dummies, which is really not for dummies. It's just a nice introductory to Redis. You can probably read it in about 3 hours. There's also one with lots of examples called, oh gosh, I forgot what it's called. There's another one there about microservices, and then a third one there, Redis in Action, I think is what it's called. And that one actually has a lot of use cases in there and examples that you might use it for. So check that out. And finally, it said, oh yeah, here's a question. Good question, Jose. Is this database only in memory? How can you work with it as a distributed system? Actually, Redis is very popular with Redis as a distributed system. The reason why it's so popular is a lot of times you're working with systems that must be very fast. And the information is not easy to, let's see, if you try to persist it, you're going to have trouble. So a lot of times what you can do is you can say, I want my data to reside in Redis in memory, and I want another system to be able to subscribe to that data through PubSub or Redis streams. And then that way you can have your distributed systems maintain a connection to each other so that they get the real-time communication. But if one of the systems is disconnected, when it reconnects, it can then get all of the data it missed. I'm not sure if that answers your question. You can also put data in Redis into memory, but if you start running out of memory, you can shard. So you can actually have a whole bunch of Redis databases running, and you can use something called Redis cluster to tell it to divide up the keys among the different Redis databases so that you don't have copies of the data on multiple servers, but you do have an organized way of knowing which one of the Redis servers your key is stored at. And therefore you can put a lot more data in Redis than can fit on one server. So yeah, and then there's lots more going on there. Redis Cloud, that one I talked about, the free one, you can actually pay for that, $5, $7, $10, I forget exactly, but people have started with free accounts there and gone up to many gigs, even terabytes of data. And we do keep copies of all of your data in multiple Redis servers there, so that if for some reason one Redis instance were to fail, then the others would still have the data and you would not lose your data. So I highly recommend using the Redis Cloud. It runs on all of the three major clouds, runs on AWS, Google, and Azure. So you can use Redis Cloud. Just go to the Redis website, choose try, and then when you log in, it'll let you choose which cloud you want your Redis to run on. Okay, I think that's about it. Looks like we've answered all the questions. And oh wait, let's see here. Is there one more? Hey, Lou, it looks like we do have some more questions. Okay, hold on. Okay, which aggregation methods can I compute with time series? I am not a time series expert, so or really even user. However, I can tell you this, that it does have multiple aggregation methods. Go to redis-timeseries.io. I believe that's the URL. It will redirect you to a very nicely documented web page that will have that information for you. But it is compacting the data. So you can tell it, I want you to compact the data by day or week or month or whatever time period. And therefore it's not going to keep using up all the space of data over, historical data. It'll compact it, which makes it nice and fast for querying. But you can probably look there and find out exactly what compact methods it gives you. Okay. All right. Looks like we're done.
Great.
About an hour and 20 minutes.
You're even under time, Dave. I just wanted to thank you for being a part of this and thank all of our attendees. And definitely, I know some of our students are going to be very excited to start working with that cloud, that free tier one to start playing around. So thank you so much for providing so much information for everyone.
Hey, you're very welcome. All righty. Well, it was a pleasure being here. And let's see, actually, let's see, go back to stop share. Okay. Yeah, it was a pleasure being here. I hope you're all staying busy and safe at home while we get through this. It really is a challenge, but sometimes it gives you more time to go learn stuff. So hopefully you can take advantage of this information. And I hope to see you again sometime. And don't forget to join us at RedisConf next month. Okay. Thank you very much.
Thank you, guys. Bye-bye.
Bye-bye.